Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. This time I'll talk about my progress for the Retro Challenge 2018, portable oscilloscopes, disassembling consumer scales, making a small digital probe, and blowing a fuse while repairing stuff. Hello and welcome back. As usual, I'm going to talk a little bit about what I did last week and what I'm going to do the coming week. First of all, I did some work for the Retro Challenge 2018 April competition, which is a friendly internet competition taking place in April. I think it's twice a year, but this one is now. And the idea is to do something with retro gear. So for example, make a project involving a retro computer, make software project or whatever. My project is listed in the show notes. I think I talked about it a few times already. So in short, it is a Commodore 64 cartridge adapter sitting in between a ROM cartridge and a Commodore 64. And you can do nice stuff with it. So what I did last week with that project was Rita schematics, because I left off about half a year ago. And to be honest, I wasn't completely sure what I was doing again. So I had to reread my own stuff in order to know, what was going on. I had to make a small hack using a couple of wires. In short, the Commodore 64 would emit a very short pulse. My cartridge involving a PCB would have to read that pulse, and the microcontroller pin input, which was used to capture that pulse, was not interrupt driven, so I would have to pull it, and I don't want to do that, so I rerouted it to a pin with interrupt capability, so that's fixed now. Also, I read up a little bit about Commodore 64 cartridge adapter signals, because they're used in my project, so I have to know which each signal is. And then most of the work goes into documenting it, so making a nice web page entry that you can see in the show notes, and so other people can also see what you're actually doing. That's the whole point of the Retro Challenge, so to share information. At least that's what I understood of it. So in the coming few episodes, I'll probably gonna talk a little bit about my progress for this Retro Challenge, as long as it's relevant for the podcast. Subject that comes up here every now and then is whether or not to get a portable handheld oscilloscope. Now what I do currently is I have a Rigol not so extremely cheap scope here at home. It's double-sided, taped to the bench to prevent me from taking it anywhere, so that seems to work. And as a travel scope I have also a Rigol, a cheaper one, Rigol DS1040I, which is a 40 MHz 2-channel scope, and I'm pretty happy with that. It's not the best, but it works. Except it's pretty big, and you need a power cable for that, and so on. So every once in a while I'm looking for a small handheld scope to take with me. Now, short answer is I'm not going to get any, because either they're too crappy or too expensive. But what I'm going to do is go through some scopes, some that I tried, some that I didn't try but may be nice, and some that are absolute crap. This may or may not be interesting, as is everything on this podcast. So, the ones I tried. First of all, there was a Velomon HBS1040I, which is a small one-channel handheld scope. It's really small, you can fit it in your pocket, and it has a rechargeable battery. You can charge it not through USB, its own adapter I think, or a USB adapter piece, so that's a bit weird. Officially I think it's a 10 MHz scope, but that's a bit optimistic, so 1 or 2 MHz sounds more like it. It is very crippled, but that's not always a bad thing. It's very crippled, but it has I think only 4 buttons, so you can get what you want pretty fast. If you use it a lot, it's quite easy to operate it, but it only has one channel, so if you want to see a data and clock signal or something with relation to a trigger signal or an event, it's not going to work, so eventually I tossed it away, and because I didn't use it anymore. Next thing I used was a Seed Studio DSO Nano scope, which looks nice. It's a very slim, flat thing with a nice bright LCD display and 2 nice probes, and everything looks nice. You have nice menus on the screen, and so on and so on. But I evaluated it for work because I was looking for a portable scope to give to the engineers when they were going on a trip somewhere. So I made a small manual of it and I did a short evaluation, but For me, it's not interesting because it's much too fragile. I think I would drop it on the first day and it would probably be broken pretty soon. So the scope, mechanically it's fragile, the menus are too small, you have to go into a menu to access a function, and I don't really like that. I like the simple scope that you can, that's severely crippled, but you can operate fast. That's much more important to me than having all the functions, because if you want all the functions, you would take an actual scope, right? So there's that. Next one was the Velomon WFS210, which is a small Wi-Fi based scope, which means it's an analog front end and a Wi-Fi access point. Now, for example, you can take your tablet and connect it to this scope, and you can download an app. I think it's not all the web page in the device. I think it's a separate app on your Android or Apple tablet or whatever. And you can actually see on the screen what the scope does. Not real time, but you don't really need that. So that's a nice price. I bought it, evaluated it for about a week, and the software is absolute crap. So it's a very nice idea because you have an isolated scope. You don't need anything. You don't even need power because there's a rechargeable battery in it, and it's a very, very nice idea, I think. But the software was crap. So yeah, that's where it ends then. Unfortunately. There are some nice semi-expensive handheld scopes. For example, there's a O1 HS Series. I'm not sure if that's still being made, but whatever. I think it's a 1 or 2 channel scope series. Yeah, it's bigger than a multimeter, but smaller than an actual bench scope. And I saw a few reviews, and I think it's nice. It's about €500, something like that. Then there is the Mixig T-Book series, which I think is a tablet-based scope. I'm not sure if the front end is embedded in the tablet or they use a separate front end and connect it to the tablet. I'm not sure how it works. I saw a review, but to be honest, I forgot it because this one too is too expensive for me. For a portable scope, it's about €500, I think. Then there's a Siglent HS Series scope. It's also about €500-600 and also looks nice, and it would be nice, but yeah, it's too expensive for a portable scope for me. And I think all of these, maybe with the exception of the Mixig, have a built-in multimeter. It's probably not the best multimeter or the most easy multimeter there is, but if I can avoid having to bring my multimeter as well, just take a scope, then I would gladly do so. So I don't care if the multimeter is actually crap or not. If you have to bring a multimeter anyway, I would bring a good one. But if I can avoid bringing a multimeter by bringing just one device, I would happily accept the crappy multimeter, so let's say that. But these three are all outside of my price range. So then there are PC-based scopes. There is the O1 VDS Series, which looks pretty nice, and I think I saw a review of that and I was pretty impressed by that. Except I think it has a USB connection to a PC, where you actually run a program on the PC to connect to communicate with the scope. So that means you need a custom program for that. It's not an app, it's not a web page, but you need an actual program for that, and it's Windows only. Now, I don't run Windows, I run Linux on my PC here, and I could probably get Windows software to work, sort of, but I don't think so. So I really want to avoid that stuff. And by stuff I mean PC-based scopes. Another one that I mentioned because it may look interesting is a Lab Nation Smart Scope. I never heard of until about a week ago. Also USB-based or USB connected scope to a PC or a tablet. And I saw there is actually Linux software for that, and Android software and iOS software and whatever. So that's seems very good supported, very well supported. So I don't know how good it is. I saw a review of that which didn't tell me much. I think they use a very simple input signal and saw that something was moving, and then they called it good, but I don't know how well it actually behaves. My experience with this sort of stuff is that the hardware may be okay, but the software may be a total piece of crap, because they can ship stuff when the hardware is ready and the software they can do later, but chances are I'll never receive this software, or the software will never exist, the good software. So I'm a little bit skeptical about PC-based stuff, to be honest. So if anyone has a Lab Nation Smart Scope, I would be happy to take a look, but until then, let's forget it. So, and finally there are what I call Toyscopes, for example home build scopes, or using an Arduino and an ADC as a scope, or solder yourself scope kits. These are 200 kilohertz scopes, and I think that's optimistic, probably 200 kilohertz. And to be honest, no, I don't even want to try that. So in short, I'm not going to get a portable scope soon because it's too expensive, and the nice ones are nice ones are too expensive, and the cheap ones are too crappy. Now, if that didn't put you to sleep, I have another boring story involving disassembly of a consumer scales that I got from a thrift store. Last time I got a toaster from a thrift store. This time it was a coffee machine and a scales. I didn't do anything with the coffee machine yet, but I disassembled the scales. So, there were 4 at each corner of the scale. There was a load sensor or strain gauge module embedded in the foot of the device. Well, in short, I have some pictures and the show notes about this. I disassembled it until it was as small as I could disassemble it, basically, and at the root of the thing was a strain gauge, or at least a resistor device that changed resistance when you deformed it, so it can increase probably or decrease if you bend it the right way. And each such sensor had 3 wires coming of it. Now, not to go into too much detail, but I don't understand why there's 3 wires. If you look at the picture, it's basically 2 resistors that are approximately 1.6k ohm idle when no weight is applied to it, or when a metal sheet is flat. When a metal sheet is bent, both of these resistors decrease in value. And there's one of the wires is where the 2 resistors touch each other when they make contact, and the other 2 wires are the ends of each resistor. So I don't understand why there are 3 wires coming off the sensor. If you know, please let me know, because it's interesting. I would have suspected that one of the resistors, so to say, one of the halves of each sensor would not change resistance. I would just be a reference resistor. So I don't actually know how it works, but I cannot, it's okay for now. I cannot disassemble it anymore, so I had my fun. So next week is the coffee machine probably. And something else I did earlier today was make a small digital probe to see if a pin is high or low or floating with respect to a ground and a power rail. So basically it's a very small PCB, it's a strip board PCB with, I'll put the schematics in the show notes and also a picture of the thing. It's basically dual comparator, I don't know how to pronounce that, with some resistors and 2 LEDs, a red one and a green one. So you can see if it has 2 wires going to some power rail and a ground, and it has 1 pin, pogo pin sticking out, and you can push it where you want to probe the voltage. So if the voltage is higher than 2/3 of the power rail, the red LED will go on. Only the red LED will go on. If it's lower than 1/3 of the power rail, the green LED only the green LED will go on. And if it's in between, red and green will both be on. So you can see the line is floating. Actually, I wanted to build it a long time ago, but now I really wanted it because I want to, for the retro challenge, the cartridge adapter has tri-state buffers, and I want to be able to quickly verify whether output pins of the buffer are actually driven or not. So whether the buffer is tri-stated or not. And I can do that with the thing. It saves a lot of time, basically, if you want to do it with a multimeter or something like that. So there's that. And that whole thing took 1 hour to build, excluding 45 minutes to fix a bug. And the bug was that this LM324 comparator probably has an open collector outputs. Now when I see open collector, I immediately assume that active is low. However, this didn't work that way, so active was high. So basically I had to invert the inputs of each comparator to fix it. What I did later today was go to the retro repair place again in Utrecht, and had a good time. Tried to fix a TV, or at least poke at a TV with a DMM and a scope. And in the process I blew a fuse because I made a rookie mistake of connecting the ground of the scope probe to something that was mains referenced and not ground. So that was fun. Yeah, I had a nice talk, but I didn't do anything useful, so that TV is still standing there, still as broken as it was. It's even more broken now, but maybe someone else wants to take a look at it. But I had fun anyway, learned some new stuff. Some guys were there who have more experience fixing TV, so it's nice to learn some stuff. What I also did was send a small letter to MakersBase, that is MakersBase, not Maker Space, in Breda in the Netherlands, which is a fab lab or hack space, whatever you want to call it. They have some nice machines there, and I've been there one time. Nice atmosphere, and so I heard they had an opening or possible opening for someone working there on an hourly basis to do some work or support or coaching or whatever. Since I'm trying to do a little bit more social stuff, maybe that's nice. So I applied, and let's see what happens. Next Tuesday I'll go to a Hackalot monthly meeting. Hackalot was the upcoming maker or hack space or fab lab or whatever you want to call it in Eindhoven, where I live. I wanted to go there last month, but something got in the way, so let's do it now. And also I'm gonna work on my retro challenge project, because we're about 25% in along the way, time-wise, because it takes the whole of April, but I don't have the feeling I'm 25% in effort-wise, so I'll have to do a lot of stuff, but that's nice. And it's also nice to document it. It forces yourself to think about stuff and to make decisions and to actually finish something. So we'll see how that turns out. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye.